Number 3 for the inverse Laplace transform. So question number 3, we have x divided by x squared plus 4x. So we put this into our inverse Laplace operator. X squared plus 4x, and then we can factor out the denominator and divide by x, so x plus 4. Okay, and then we have to do the partial fraction expansions, meaning that we have to equal this with the inverse Laplace transform of a divided by x plus b divided by x plus 4. And this will be very easy for us to find what is the a and b. So from this, we equal the coefficient value, that means a multiplied by x plus 4 plus bx, then that must be equal to the numerator value, which is 8, right? So we do the expansion here, a of x plus 4a plus b x must be equal to 8 over here. So accumulate the x of term, that means a plus b multiplied by x plus 4a must be equal to 8, right? Now from this case, we can see that because on the right hand side we don't have x, that means we can use the equation here, which is the 4a must be equal to 8, and then we can find what is the a value. A is equal to 2, right? A equal to 2. Okay, now for the a plus b over here, since the right hand side of x is 0, that means a plus b must be equal to 0, and then we can find what is b. So b is minus 2, and then we substitute a and b into the equation over here. We substitute this a and b, okay, to these functions, and we evaluate the inverse Laplace transform. So the inverse Laplace transform of a divided by x, which is 2 divided by x, and then we have plus minus b, which is minus 2 divided by x plus 4. Okay, so we evaluate this inverse Laplace transform term by term. Okay, now we take the inverse Laplace transforms of the each term separately, which is 2 divided by x, then plus the inverse Laplace transforms of minus 2 x divided by 4. Okay, so we can shift off the 2, that means inverse Laplace transform of x, 1 over x is equal to 2, right? And then here we can shift off minus over 2, that means we are taking the inverse Laplace transform of 1 divided by x plus 4, which is equal to exponential minus 4 of t. Okay, so this is the answers for the inverse Laplace transforms, question number 3.